In this video, we're looking at sketching exponential functions. So when you're sketching exponential functions, there's a series of steps that you need to follow in order to sketch a decent function, I guess. If you follow these steps, you shouldn't have it should be fairly straightforward. Try not to stray too far from this path. So we've got y equals e to the x plus d. I've just written a very, very simple general form here. We can put plus c's in here and b and a's everywhere. But I just wanted us to focus on this plus d for now. So you've got your exponential function and something on the end. That something on the end is going to determine where the asymptote is. That's the point at which the graph gets closer and closer and closer, but never ever touches. So our d value is going to represent our asymptote. That's really all the information you need to be able to sketch any kind of exponential function. Let's take a look at an example here. We've got y equals e to the power of x plus 3 plus 4. Now, first step, so step 1. Ask yourself what the basic shape of this graph is. Now, it could be e to the x, it could be e to the negative x, it could be negative e to the x, or it could be negative e to the negative x. Now, this one's the simplest, it's e to the x. So that means that it's going to have a basic shape that looks like that. Okay, asymptote heading out this way and heading up out into the sky, like that. So that's step 1. Now step 2, really, really straightforward. Ask yourself where is the asymptote? And really, really straightforward. Look to the end. Sometimes it's at the front depending on, look to the back. Sometimes it's at the front depending on how they've written it, but it's our d value. And in this case, the asymptote for this equation is going to be 4, which means that if I just continue my little sketches here, it's going to look something like this. It's going to go up out into the sky like that, and it's going to have an asymptote that it never ever touches, going along here at y equals 4. So there's our asymptote. Okay, now you can see that this is never going to have an x-intercept. It's going to have a y-intercept, but it's never going to touch the x-axis. And so our next, and that goes for all exponential functions are going to have a y-intercept. So that's something that we can add to our sketch. So step 3 is find the y-intercept. Now remember, to find the y-intercept of anything, you should let x equal 0. So I'm going to do that now. Y equals e to the power of 0 plus 3 plus 4. That's just e to the 3 plus 4. I'll just grab my calculator if I can find it. Alright, so if we type that into our calculator, we'll get e to the power of 3 plus 4. That'll give us 24.08. So that tells us our y-intercept. So now we've got a whole bunch of information here. We have our basic shape, we know our asymptote is at 4, and we know that our y-intercept, that is that point right there, is equal to 24.08. So I can start sketching this at least somewhat. Try to be a little neater than I am. Asymptote here, make sure you put a little dotted line in for your asymptote. And I might just name that line as y equals 4. And then I will sketch, I'll use a different color there. I'll sketch in my basic shape. And this point is 24.08. Now, unfortunately, we're not finished. There's one more step here. Step 4. Now the problem we face is that because we're only putting one single point on this line, it's not a very good sketch. So what you need to do in step 4 is find a significant point. That just means you need to let x equal something and then find another point. So I'm just going to, and this is what you should do, I'm just going to let x equal 1. Now if they curve up the other way, let x equal -1. So if you're using a function that has a basic shape that looks like that, use x equals -1. If you're using a function that looks like that, use x equals -1. Alright, so I'm just going to let x equal 1 and then sub it in. So y equals e to the 1 plus 3, so 1 to the e equals 1, e equals 4. Sorry, y equals e to the power of 4 plus 4. Now again, pull your calculator out. Where is it? Okay, and we end up with e to the power of 4 plus 4. 58.60. Okay, so we can finally put in our last point. Okay, there's our significant point. It's going to be 58.60. Now, this sketch here is essentially your finished answer. Now, when you do this sketch, make sure that once you've done it once in sort of an ugly way that I've done it, make sure that you do it in a much neater fashion and try to draw it to scale. You can see the distance from 0 to 4 and from 4 to 24 is very similar. It really shouldn't be. That distance should be 5 times bigger than this distance here. And the distance from there to there should be double whatever that distance is, because that's 24 and that's 58. So just make sure you try to draw it to scale a little bit when you actually do it. But if you follow these 4 steps, what's the basic shape? Where's the asymptote? Find the y-intercept and find a significant point. You shouldn't have too much trouble. There is a 5th step, step 5. Find the x-intercept. But that's only in cases where there actually is an x-intercept to find. We might do one more where there's actually an x-intercept to find.